This video is to address a few things from the thinning lab. So the first thing we'll go over is the course website and how to do all of our thinnings. So this is the course website. We'll be using the thinning assignment handout along with the thinning lab PowerPoint. On the thinning handout, we can see this is how we conduct all of our low thinnings, free thinnings, mechanical row, and row combos. Additionally, we can look at the PowerPoint here to understand how all of our high thinnings and low thinnings and crown thinnings will work out, and how we should use the data to address all of those. Now here's our main data. You can see we have DBH, form, and crown class. DBH is represented by the diameter breast height, just by a solid numeric figure. Our form class here is to represent either good form or poor form, and our crown class here represents suppressed or unsuppressed. Now this data was created using random generation from Excel, and that means that it's just fake data and it doesn't conform to what you'd likely expect to see in the real world, and my graphs may look a little different from what you could expect to see. So the first thing we'll have to deal with is the low thinning. This involves removing trees that are in the lower crown class and some poorly formed or undesirable codominants. This will leave essentially codominants and dominant trees. This is also called a thinning from below. So here we have that same raw data, just laid out in a different size here. So the first thing that we're going to do is write some if functions. These are Excel statements that take some input, check it against some criteria, and then return some value if true and a different value if false. We can see the low thinning, because it focuses on trees of poor form and trees in the lower crown classes, we're actually not going to write any functions for the DBH classes here, as it's not a factor for our cutting in this method. So this first function essentially mirrors our data. And this may or may not be applicable for your data depending on what your 1 and your 0 represents. I prefer to do it this way to keep all of the data in the same line. So if our function looks at cell I3 and asks if I3 is equal to 0, if it is, then it returns a 1, and if it's not, it returns a 0. That can be seen here. I3 equal to 0, logical test, the value if true, 1, the value if false, 0. This is essentially mirroring the data, and since it's already in a binary value, because in my data's case, in the form data, a 1 is equal to being good form and a 0 is equal to bad form, this second iteration of the data says the opposite. The second set of data essentially tells me that a 1 should be a tree I should consider cutting. The same thing happens in the crown class, as a 1 is a dominant or codominant, where 0 would be a suppressed tree. The same if function applies here and asks the data the same question. Here we can see we're checking if P3 is equal to 0. If it is, return a 1. If it's not, return a 0. So since it's equal to 1, it returns a 0 here. So the reason I've turned these and mirrored them is that it helps me understand that a 1 is a tree I want to cut and a 0 is a tree I should keep. So in the third iteration of the data, we're using a sum function. This is the third iteration. So we're essentially asking cell B45 if cell P24 and I24 for their numbers and then totaling them. This leads to an array of data with 3 possible values, a 0, a 1, and a 2, if we were using the DBH as well. So zeros being trees that we should keep because they have good form, they have good crown class, and a 2 being a tree we should highly consider removing because it would have a low crown class and a poor form. We then turn that data back into a binary value by writing another if function that asks if cell B45 is greater than or equal to 1, then return a 1. If it's not, then return a 0. This is helpful in creating our graphing portions. So from here, we can sum up all the trees that we're cutting compared to the trees that are total. And we can see that we're cutting 33% of the trees. Now, this is a reminder that just because we're removing a certain portion of trees, that doesn't mean we're removing that much biomass. This is because we're explicitly choosing trees we think are worse, and trees in this thinning method generally correspond to lower DBH trees overall. Now, to graph all of this, we'll bring in the original DBH data. We'll bring in our final cut array, which is this guy. And this essentially tells us which trees should be cut and which trees we should keep. So if the function returns a 0, that means the tree should remain, whereas if it returns a 1, that's a tree we should cut. So essentially what we're doing here is we've written another if function that will look at the cut and decide whether it's equal to 0 or not. If it is equal to 0, meaning we're going to keep the tree, then just transfer the DBH data from here to here. Whereas in this cell, we can see that we are cutting this tree, which means that we're going to remove it, so it should return a 0. Now, we'll come over here. So we can see we need to figure out the first thing is how many DBH classes we need. So in order to figure that out really quick, we're going to use the max and min functions. So equal min, and this essentially returns the smallest value of any array, so 9, and equal max, the same thing, will return a value of 22. So 9 and 22. So we've essentially written 9, 10, 11, 12, all the way over to 22. Once you have a few of them, you can click and drag and bring them all over. Now, what we're doing here is a COUNTIF function. So we've given this array here. We've made sure to put cache signs in here so that our array doesn't move. And then we're essentially asking it to count all of the numbers if they meet some criteria. This criteria here being DBH. So we have brought all of this down. And then we essentially want it to count if all of these numbers. So in our cut, there should be 8 of 14 DBH class. In our original, there were 10. So that gives us a chart that looks like this. We've essentially just highlighted all of this data, insert, line, 2D line, add, axis titles, and then on our data here, we're going to turn off DBH and apply that. But we can see our axis titles here aren't reflective of our DBH, right? So what we need to do is right click, select data, edit, select this, okay, okay. Now we have 9 through 22. We have how many trees were in it originally, that's the gray line, and how many trees are in it afterwards, that's the orange line. Your orange line of cut should never exceed the original, so keep that in mind. The difference in between these lines being all the trees that we've cut along the way. So you should additionally add some axis titles here, being like DBH class, number of trees cut. Should have a chart title here telling me which cut it is. Don't use OG, use original or pre-cut, post-cut. And that's pretty much how all of this is done. So, thank you very much.